All right. Now we're going to take a look at the software installed on the on the supercomputer. What comes with a supercomputer is not just the hardware, but we also provide a software suite already installed on the system for people to use. When you use the command line tools such as SCP and CAT, you have on the supercomputer. A supercomputer is basically it's a Linux-based system. So you all have those. If you're familiar with Linux, you have available all those commands that you would usually find on your laptop. But there are a few things that are different. The first thing that is different is that you may have multiple versions of the same software required to be installed on the system. For instance, a scientific application such as one it's called LAMPS, users may want different versions of the same application. So to handle the complexity of a software stack, of the software stack of a supercomputer, we use a system called modules, and that's why this part of presentation is called using software modules. Also, a supercomputer, let's move forward. A supercomputer has similarities and differences with your own laptop in terms of software. And during this presentation, while I cover this module, you will learn the main software categories that are installed on the Pawsey software stack. You will understand what is the module system and how to use the module command to load and see the software that is available on the system. And basically using the module command to explore the software available and make use of it. So a software stack, what's that? A software stack is a collection of software packages together with all their dependencies. The software stack is made up of end user applications. So those applications that you run to analyze data, for instance, LAMPS or VASP, but these are molecular dynamic applications. There are various applications for various science domains. You may be familiar with some of them. Other software are library packages, so numerical libraries that implement common linear algebra routines, for instance. I/O libraries that handle the reading and writing of data, especially with when there is the need to read or write large amount of data. There is specific software written for you to for such use cases. On Cetonix, we have different layers of software stack, or better, we have software that is built on top of other software in a dependency tree-like fashion. So the supercomputer, when was bought by Pawsey, came with a Cray programming environment. So it's a software that the supercomputing vendor provides the users to make use of the supercomputer. It includes optimized compilers and numerical libraries. You can use those to compile your own software and write your own software in such a way that it makes optimal use of the resources on the supercomputer. On top of that, Pawsey, that is Chris, myself, and other people, install additional software on the supercomputer depending on the needs of our particular user base. So for instance, we have a big radio astronomy community and bioinformatics community, so we provide a lot of software already installed on the system for them to run so that they don't have to install the software, optimize the software themselves. Not everybody develops software. People are happy to use the software we provide. We have three different layers or levels to the software stack we provide. We call the system-wide software stack the software that is available to all users, and it is installed and maintained by Pawsey staff. So you just need to load it, and then you can use it. We are responsible for updating it and fixing it if there's something broken along the way. But users can also, and projects can also install their own software in their own private location that is visible to the whole project or just the user that installs it. And that's why we have a project directory for the software you install for your project, for all the members of your project. But also we have a directory dedicated to only for the user, for yourself, where you can install and place your own personal software. So there are 3 layers here that we support. On top of that, and this is mostly for compiled software, we also provide the ability to run containers. We will see what containers are. Basically, they allow to bundle software in a file and execute that file as if it was an independent machine, an independent operating system, or independent bundle of software. We'll see that later. What if you need to install your own software? Well, we provide several options for that. You can build your own software from scratch. If you ever built a software, compile software yourself, you can use make, CMake, and you can call the compiler itself. But if you need to build a package that is fairly popular, we also provide a packet manager called SPAC. SPAC is a software that basically downloads the source code of a software and it builds it and installs it according to our configuration, such that with a single command line, you can install a software and its dependencies, and it's made available to you through the module system. For Python, that is mostly for compiled software, so like written language like C and C++. For Python or R packages, we suggest using pip or the packet manager that comes with Python. Those also have been configured on Cetonix to work nicely with the environment we set up. And the environment is basically, as I said, handled by software modules. A module system is a software utility to organize and manage multiple software packages and versions at once. So on your laptop, when you install your software on your computer, it all goes, if you are a Linux user, it goes under user bin or in a pretty fun location. But that will also mean that it's hard to have multiple versions of the same software. You don't know which one are using at a certain time, because we need to support users who have different requirements for the same applications. We do not install software under the usual Linux locations, but we install them, and as shown before, we install them under the software Cetonix location. That is not a location that is known by Linux, but we make it available and known to the Linux system through this module system. So a software module is basically a file that it contains commands that set the shell environment such that the computer then can find those files or the software you want to load. The module list and module avail commands are there for you to see what is currently loaded. That is, when I say loaded, one module is loaded, what module or software is visible to the system at that time. For instance, this module list is what you can see when you first log into Cetonix. You see that there are a few module software available. One of the software is GCC, it's the default compiler on Cetonix. So it's already loaded, and then you can type GCC on the command line, and then it finds the program. Module avail, instead, will list all the modules or software that are available on Cetonix. If you run the module avail command right now, you will see that there is a long output because we have a lot of modules installed for the users. A few notable modules: the PRGM or Programming Environment GNU is a module that will set up the environment, the programming environment, such that it uses the GNU compiler suite to compile and link and run the software. Cray and Pitch is the MPI implementation that is used on Cetonix. MPI is the message message pass interface, a technology that allows multiple processes to communicate together across a single or multiple nodes. So it's an important software that is being used on Cetonix. It allows programs to scale on multiple nodes, and it's already available there. You just need to load it and use it in your compilation process. Module avail without arguments will list all the modules that are available there, but you can also restrict the content of the output by providing a string, which is used to filter out the module name. So, for instance, if you know you're going to use this software NWCam, and you want to see whether that is installed on the system, then you can just simply type module avail NWCam, and then it shows all the NWCam modules available and versions. In this case, in this example, we have just one module available, one version, and people can use it, use that module to then use the software. You can search for Python or other packages you might be interested in. There are different programming environments available on Cetonix. So as I said, the Cetonix came with pre-installed software, and programming environment is one of the most important ones. It basically set the compiler and libraries to use with the compiler. We have different options available. We have the programming environment based on GNU, so the GNU compiler suite, or we can also have the programming environment developed by Cray itself. So Cray was a company that first started the supercomputers. First started building supercomputers, but then it got acquired by HP. But the name of the module is still called Cray. The Cray is another programming environment providing some compiler and optimized libraries. On Cetonix, we use the GNU environment by default, and that's what we mostly will be using. All our software is built mostly on the GNU environment. We also provide a software stack based on the Cray environment, which is particularly useful if you write Fortran code, but we will stick to GCC for now. So I can try to. Is there a way for me to show? Okay, there it is. Okay. So. Okay, I have a shortcut in the way I log into Cetonix. Bigger, okay.
If you can also, increase the font a little bit. Yeah.
Now, where is the cursor? Okay, so wide. Okay. So if I do now module layer, it will take some time. So there are modules are organized. Well, modules basically have a name / a version. This is a module. They are organized in directories, so they have a directory-like structure. So you can say a group of modules that are semantically cohesive. It's logical to stay together. They are under the same directory. So we have a few modules which have kind of a arcane name. Here, this is the module provided by Cray, by the vendor of the system. They are usually not directly used by yourself, but then you can see another directory here. You can see the directory changes and goes to software. This is an indication that these modules are installed by Pawsey staff or yourself. In this case, you're seeing one of my projects. These modules are my personal modules because are installed under my project and under my username. So the path is under my username. These are my personal modules that only myself can see. You cannot see these modules because are mine personal. If you scroll down, then these one are modules that I've installed for this project. So there is no username following here. So this is visible to all the users within the project. And then what you see here, a different directory is another different directory. In this case, we have software Setonics, date it was deployed, and etc. So in this case, there is no project here, no username. So this is the software stack that is visible to all users on the system. So if you do module aware, you should be able to see this set of applications. And we group applications or modules based on the use cases. So this is all the applications to support the radio astronomy community we provide ourselves. If I scroll down by pressing the space key, you can go down and see libraries. So these are all the various libraries we provide to users. They can use them to compile their own software. Programming languages, utilities, and etc. So we organize software by compilers, by categories, but also we also organized. They are also organized by categories here, Python packages, but also they are organized by compilers. So what compilers I've used to compile, or Pawsey has used to compile the software, and the CPU architecture. Because if you change compiler, change CPU architecture, then you will see, the software will change. Okay. We'll see that later, but any questions so far? Okay. So there is an exercise here for you. You can, if you want, you can quickly go through these exercises. You can use the commands that I've shown you so far to try and answer this question. So I'll give you a couple of minutes to familiarize with that. Oh. Okay. Do it with you in the meantime. Okay. Okay. So what I would do for the first one is module avail Gromax, and then we see we have 5 different versions. For instance, in this case, we have the version of the software, but also the way we compiled it. So in double precision, mixed precision. This, if you see modules with this particular suffix in their name, that means that that module has been compiled with GPU support. Okay. Then well, you can try to search any module you want. If I do CMake version, it tells you there is no CMake version. There is no CMake installed on the system the way you would install on your laptop, such that there is no apt install CMake. You cannot install software by the way, you cannot install software on the system the way you install it on your laptop because you don't have root permissions or administrative privileges to install software the way you would on your laptop. So if I do module avail, then load CMake, assuming there is a module named CMake, what happens now is I get this error. It tells you that the default module versions are disabled by your system administrator. I mean, when you load modules, we want you to specify the versions. This helps with reproducibility, so we know what when you provide us information what went wrong in your computation, we know exactly what version of the software you were using. So if I do module load CMake, a shortcut that I usually do, you can use tab completion to see. In this case, it completed everything by itself because we have just one version of CMake. If you had multiple versions, it would list all the versions available if you do tab. Now, if I do module load, then I do CMake version. Now I have CMake available on the system. And this is true with other modules as well. This is basically what it does. If I do module show CMake, and this is what a module file is essentially. So it's a bit of a mess because the paths are long. But if you're slightly familiar with Linux, what it does essentially, it prepends the location of the software to the path environment variable and other paths such as CMake's prefix path and others. Since it's not a library, it doesn't set the LD library path. Otherwise, if it were a library and you would have to link that library to another application, it would set other environment variables as well. So the module system, what it essentially does is manipulates the environment of your shell such that the software is then found through these environment variables. Okay, trying to speed up a little. We've seen this. Module hierarchy, well, very quickly is what I basically said is that software is organized by categories, but also by compiler and architecture. If we get a new compiler, we need to recompile the software with that compiler because we want the software to be optimized with that compiler. Or if you need another CPU, if we have another CPU, we want the software to be compiled for that CPU. An example of that is the data mover nodes. The data mover nodes or the nodes in the copy partition, they do not have the Zen 3 or the AMD Milan CPU. They have the previous generation, the AMD ROM architecture or Zen 3 or Zen 2. And for that reason, the software for that particular architecture is installed under another path or hierarchy, so under the Zen 2 hierarchy. You can when you log into the data mover nodes or copy partition and you load a specific software for that partition, then you will notice that the software is in the path under the Zen 2 architecture. That is done everything for you when you log into the data mover nodes, but we also provide software compiled with the different programming environments. You can use the command module swap to change between programming environments, and that will also change the software stack you're going to use. So you can choose to use the software stack based on GCC or on the Cray compilers, for instance. I don't want to go too much into details into that because it's quite advanced, and unless you really want to use the Cray compilers, I think you're better off just use the default hierarchy. But it's something you need to be aware of. You can do it. You can change software stack based on the compiler you want to use, or even based on the programming environment, and sometimes, not in our case, I believe, but also depending on the MPI implementation you want to use. Yes? So when you use Python to, when we installed the software stack, we found that the GCC, the binaries produced by GCC were more performant than the Cray compilers by, I guess, a significant amount. Just then we decided to go to compile the software stack with GCC. But the Python interpreter compiled with GCC might be faster than the one compiled with Cray. Now, I'm not sure whether that is still the case, but we stuck with GCC. But in other cases, such as Fortran codes, if you have a Fortran code, it seems that the Cray compiler for Fortran is better than the GCC one. And so there are users who have Fortran codes that prefer to use the Cray software stack instead of the GCC we provided. That depends on your use case. You can try both and see what is best for you. This is all documented on our documentation as well. So if you want to experiment with that, it's all there. And here is exactly an example. So you can see if you have, in this case, we swap from the GNU to the Cray environment, and you can see there are a few messages says, okay, I'm replacing the stack with GCC with the Cray compiler based one. And if you load Python in this way, you see that now the path is based on the Cray compiler here. So it's a completely different path than, let's say, if you swap back to GNU, the module system recognizes the swap and essentially loads the Python module that corresponds to the GCC. So it's a completely different path. The module system modifies the environment to point to the Python that has been compiled with the programming environment that you choose. Okay, so this is a list of commands. Most use commands you can use with module. So the module is the command, then you have subcommands. So list available, list gets all the loaded modules that are currently active. The one available shows the one that are currently available on all the modules available. You can filter them by using a string. Module load loads the module, makes the software visible to the system. Unload removes that module. Unload the module means that hides now that software is not reachable anymore. Swap, you can use swap to change between versions of the same module, essentially. Okay. If you can use the software we provide because it's there for you and it's optimized for the architecture, you can always install the software using SPAC or other, any way you want, really. If you use SPAC, it will generate module files for you. Otherwise, you would have to create your own module file or load the software in the old way, setting your own environment variables. We do not buy software for you, so this is not really the case for you because Adapt you'll be using proprietary software. But if you need to use proprietary software, you would have to buy the license and ask us, or either install it yourself locally or ask us to. We also provide licensed software on the system with agreements with the software vendors, but you have to show us that you have a license for it to use. So we have software available, like VASP is an example of licensed software we provide, but you would have to contact us and say, oh, look, I have the license to use the software, give me access to the module. But we do not buy license for you. Yeah, we basically learned about the software stack and now you can use with the module system. Since you will be working on experimental projects, you'll be finding yourself compiling software or maybe trying to install different dependencies. I think it's not covered in these slides, but how to use SPAC to install software is something that you probably may become familiar with, and we have an extensive documentation on how to install software in various ways on the system. So please make sure to take a look at that. If in any case, you can always write an email to the help desk, and then we will point you to the right direction in case you need to install software. Okay. Any questions so far?